Welcome guys. Welcome to my Leetcode solving section. So today let's solve this 997 find a town charge. So before I start, please subscribe to my channel. Oh, by the way, so most of the Leetcode solving section are just solved by and I'm from like mathematics background. So I just share my idea. So maybe my idea is not the quickest way, but at least you can solve the problem. Okay, so hope you guys subscribe. Okay, so 997 it basically is the find the town charge. So in town there's n people labeled from 1 to n, and there's a rumor that one of the people is secretly the town judge. Okay, so town judge means who cares, right? Just a judge. A town judge chooses nobody, right? So that means and everybody's the town judge do not trust anyone, and then everybody trusts the town judge, right? Okay. There's exactly one person said it's proper. If you have these three criterions both work, then there's a town judge. So you are given an array. Basically, trust I means that A B means that A trusts B. Okay, I mean A cannot trust itself. Okay, so if the town judge is this and can be identified, return a label of town judge. Otherwise, return -1. So for example, if for n equals to case, you have 1 and 2. Basically, 1 trusts 2, right? So 2 is a guy who do not trust anyone, and the 2 is a guy who everybody trusts him, right? So or she. Okay, so 2 is a judge. Okay, so answer 2. Okay, and let's maybe see this guy. So this guy is n equals to 3, right? So n equals to 3 is basically 1 go to 3, 2 go to 3, and the 3 trusts 1, right? So the problem is that there's no such guy. There's no such guy that who do not trust anyone, but trusted by anyone. Who do not trust anyone, but be trusted by anyone. This is very hard to pronounce. So -1, and this is also 1. So 1 trusts 2, 2 trusts 3, right? So it looks. So you see, since 1 trusts 2, right? So 1 cannot be the judge. 2 trusts 3, right? So 2 cannot be the judge, right? But the problem is that 1 do not trust 3, right? So 3 also cannot be a judge. Okay, and also you can check this guy is basically a little bit difficult. Basically, it's 1 go to 3, 1 trusts 4, 2 trusts 3, 2 trusts 4, and then 4 trusts 3. Okay, so you see, 1 cannot be a judge, right? And 4 cannot be a judge. 2 cannot be a judge. The only one who can be a judge is 3. Number 3, right? Number 3. Okay, so let's see how to solve this. Okay, so I like to solve it like by logic, right? So let me just define some interesting like solving this by math. So idea is that I can define a first set called candy. So candy means that people, right? It is the people who do not trust anyone. Okay, and also there's a set S. Basically, it's a people who trusted by everyone. Okay, so somebody give you. So the idea is that we first find the set of candy, and then find a set of S, and the answer is that if candy intersection with S only 1 people, then we return this, right? Return the only element, otherwise -1, right? Very easy. Okay, so the first one is very easy. Let's do a exceptional case. So exceptional case is that if there's no trust pair, so it means everyone do not trust anyone. So if there's only 1 people, then you should return 1, right? Because he's a guy, right? But he cannot trust himself, right? So what, right? So answer must be 1. Otherwise, if you have 2 people, then at least 1 should be trust the judge. So return -1. Okay, so let's define a candy. So candy is basically the first set I need to come up with is that the people who do not trust anyone, right? So the candy I start from 1 to n. So let's assume that I have the original n people, and I take any trust pair. Right? I take any trust pair, and if this guy and if this number is in the first position, and then I should remove, right? Because he or she trusts somebody. Okay, so let's see let's say for J in trust. If J0, right? J0 is the first component in the candy, then I remove J0. Okay, so this is the condition 1. Okay, So after this, then I get a beautiful set called Candy, right? Basically, who do not trust everyone. Okay, actually, who does? Or who? What? Okay, and then I define a dictionary called the Betrust dictionary. So this Betrust dictionary is a little bit difficult, but the Betrust dictionary means that so this Betrust dictionary means that if you give some people I, then you will return all the people like I trust I. So basically, I just want to count how many people trust you, right? So if you are the judge, then the Betrust I must be what? Must be n-1, right? Because totally have n people, and you are the judge, right? So everybody should trust you. Okay, so the idea is that let's define find this. If J1 means the judge, right? People who can be judged, not in the Betrust, then I just initialize. Otherwise, that you just add 1, right? Okay, so now I can create a set Candy. I just take a set. Okay, so finally I need to find S, right? As I said, the S is basically who trusted by anyone. So basically, it's the number such I which is Betrust I is n-1. So let me just write down S. Basically, I who betrusted I is basically n-1. Okay, I should say capital N. Okay, so I just very easy. If for I in Betrust keys, if the Betrust I is n-1, I just append I, right? So we have 2 sets, and I take set. Okay, finally, I do the intersection. Enter is final, right? Final is called S intersection Candy. If there's only 1 guy here, then we have a judge. We just pop. Otherwise, we return -1. Okay, so this is a mathematical way to, without using a graph theory, only a set theory to write down everything in terms of mathematics and the set theory, and then we just do the manipulation. And we submit. Okay, it's a little bit long because we are not using graph theory. Alright, but I think it's very easy to understand the logic. Nice. I will see you guys in the next videos.